Okie dokie. Right, hopefully I'm going to be able to keep all of this on the screen and in the right place. So let's see. So next job, the next model I'm going to build is fully scratch built. I might, as things progress, buy some fittings to save certain aspects of scratch building. But what I'm going to do is I'm going to build a boat, a ship, a warship. I'm going to build it in 1/72nd scale to give it a reasonable amount of size. I'm going to scratch build it as a one-off. Technically, when the hull's finished, it could be cast. It could be produced in fiberglass and sold. It's not something I'm planning at the moment, but I might think about it when the hull's done. Anyway, what I'm going to try and do, and I say try because it's a little bit difficult, something this size, but I might set the video camera up so that it can actually film me doing certain things. But I'm going to start with an explanation session here. So a bit like a cooking recipe. I'll just move these for a second. A bit like a cooking recipe. What I've got in front of me here is the ingredients to make the hull, the 1/72nd scale hull of a warship. So we've got 3 sheets of light ply, 1/4 inch 6mm light ply. It's easy to cut, it's lovely to work with. We've got about 10-12 sheets of 3mm balsa wood. Again, easy to work with, easy to cut. Then I've got about 15 sheets of 20 thou plastic card. 20 thou plastic card. I've got black and white. Normally I would only have white, but the model shop only had half white and half black, so it makes no difference, it's all going to get primed in the end anyway. So that's the plastic card, 20 thou, A4 sheets, probably just a little bit bigger than an A4 sheet actually, tiny bit bigger than A4. There's about 15 sheets there. That will serve to help make the hull waterproof and help make the hull a bit tougher, and also help put the panel effects, the plating effects, metal plating effects on the hull. We'll deal with that later. Right now I'm going to pop that back in the drawer so it's out of the way. Super glue and accelerator, key thing for using. Accelerator just to get the glue to set easy, but super glue so that we're not waiting hours for different wood materials to dry, and it's also waterproof. Not that it needs to be, the trick is to keep the water out of the hull. Put that back up on the shelf. So balsa wood. We're going to use this to plank certain areas of the hull that won't be conducive to planking or covering with anything thicker or harder, because there will be some quite tight curves on the hull. I've got a bit of block balsa wood in case I need it, but the balsa wood there is going to be stripped up into planks basically to cover the hull. So I'm just going to stand the balsa wood out of the way so we know what it's doing there. And then here, now the boat I'm doing is called HMS Roberts, and HMS Roberts is a World War II monitor. I think a keel was laid down in 1941. I think she was struck off charge and scrapped in about 1965, and she had a relatively eventful career. She was involved in the Allied invasion of Sicily in the Mediterranean, and was involved in Operation Overlord and the Dunkirk beaches in 1944. So she's had a fairly eventful life, and she's an interesting looking boat. I love scratch building warships. I love building any sort of warships really. My chosen scales usually, if I'm building a trawler, an armed trawler, a converted trawler, 32nd scale. If I'm building a warship, somewhere between 96th scale and 72nd scale gives a reasonable size. 72nd scale for HMS Roberts is 62 inches long, which is 5'2", which is a good size for a model of a warship. But she's an interesting boat and shares something in common with all the big boats that I like building. HMS Roberts was a monitor, and as such had an incredibly flat bottom and an incredibly severe what's called tumble home. If I show you these plans here, these are the plans I'm working on, and I'll help you make sense of these as things progress. But this is form as 1, 2, 3, 4 and 5, looking from the front of the boat of HMS Roberts, that's the centre line of the hull here. And you can see she has an incredibly flat bottom, so she draws a relatively shallow draft for working in coastal waters, because she was a monitor, was used to bombard the land from the sea. And she also has a severely strong, what we call tumble home. A tumble home on a boat is the point between the gunwale, the gunwale here, and the water. And a pronounced tumble home is where if you fell off the boat, you'd tumble down the side of the boat rather than just falling in the sea. Sea being home. That's how I take it anyway. But HMS Victory galleons had tumble homes. If you look at some of the early 20th century, very early 20th century, late 19th century French and Russian ships, they had enormously pronounced curved tumble homes. Some of them looked absolutely amazing. If you look at the French first steel-hulled ship, the French, I think, ever built, but possibly by the French, I think the Redoutable, amazing shape, the whole incredible tumble home shape to the hull. There are loads of boats that share that feature from what you might call a pre-dreadnought period of time. Amazing looking boats, very steampunk in the look, and a lot of them appeal to me enormously. The thing with this monitor is this HMS Roberts, I love the proportions of it. It had a standard 15-inch turret off any of the standard battleships at the time, but it was only half the length, literally, if that. And as such, the turret looks enormous in proportion to the rest of the boat. It had the standard pom-poms and ACAT guns and things like that. And it's just a generally pleasant boat. I'll do a side view as well so we can see. But I'm just using this drawing. If I flip it over, you can see a side view of the hull here. It's got very much a normal proportional look from the side. It's only when you see it from the plan view that you see how incredibly wide it is to its length. Okay, hopefully you can see that while I'm waffling. So this plan was simply taken from the internet and enlarged to 1/3 of the size of the model that I'm producing. So you'll see, just quite simply, not rocket science, photocopied sheets printed off the printed sheets, stuck together. 3 times that will give me my model, so it's a good working point, and I can take dividers and just size up and things like that. These, however, have been drawn actual size, so these are the actual formers, and I've printed these out to be the actual size of the formers that I'm going to produce. If I just don't confuse the issue by just having one. This is the centre line, and we can see formers 1, 2, 3, 4 and 5. And then again, here is the centre line, and we can see formers 6, 7, 8, 9, 10, 11, 12 and 13. We can also see the position of the prop and the position of the rudders. Now, there's a few things to design in model boat hulls and designing models in general, like tricks that you learn, tips that you learn. The first thing I'm going to tweak that will make the boat not entirely scale is I'm going to move the prop shaft up a little bit, the centre line, and I'm going to put a fractionally smaller prop on, so that if I sat the boat on flat ground, the prop won't dig into the ground. In other words, the propeller will be protected by the bottom of the hull. It'll make zero difference to the performance of the boat if you put it on a pond. But it means the prop won't be damaged. The same thing, I will increase the ruddering chord, but I'm going to decrease the ruddering length. So again, it won't interfere if you sit the boat flat on the ground. It wouldn't be a good idea to sit it flat on the ground, but you know, if you're on a pond, it could be pebbly, you could damage the bottom of the hull, so it should be sat on a stand. But it makes a big difference in terms of working on the hull in my workshop. Okie dokie. So the first thing you've got to do is turn these drawings into usable drawings to create components from. And one of the things to bear in mind when I'm doing this is what I'm going to do, because it's got such a flat bottom, I'm going to use a single piece of this quarter light ply to create the bottom of the hull. The bottom of the hull, if I just do a quick sketch on my drawing here, will probably look something like that. I've drawn that really badly. But the flat aspect of the bottom of the hull will look something like that. So that's the first thing I'm going to construct shortly. And I'll construct that, and then I'll take you through the stage of its construction and show you what I've done. That's going to serve as the point from which I build the rest of the model, if you like. That's the keel I'm going to lay. Now, the first thing that becomes apparent if we look at this hull is the fact that from here, if we number quite simply, look, I've numbered them, 1, 2, 3, 4, 5. So I've numbered the formers so I know where I'm working. And I've put the letter S at the top of these 4. And that's because those 4 formers here, from this position on the hull, which interestingly, the hull, by the way, the deck is entirely flat, and then it has ever such a slight shear line climb from former 5 forwards, but the hull's still flat, so it's almost like a kink in the hull rather than overall curve. So in a sense, that makes the job a lot easier to build the model, because you're not building that shear line in. Anyway, back to what I was talking about. Those 4 formers are the same. So I'm starting with those 4 formers. I'm going to create the bottom shape that I've just shown you, that we've just talked about, and then I'm going to create these 4 formers. And in order to save material, and to a slight degree weight, you don't need to worry about weight like you would if you were modelling a flying aircraft. But it's important on a model boat that the weight is as low down as you can get it. Not so much possibly on this with a big flat hull like this. It'll be incredibly stable because it's completely flat. But still, I don't want weight where I don't want it. And I also don't want to waste material and use material, because the trick is to make it as cheaply as I can possibly make it. So, using this drawing here, what I've done for formers 5, 6, 7 and 8, they share the same outline. So I've picked a point that gives me plenty of surface area here where those formers can contact the deck. And then what I've done is I've removed 6mm at the top of the former. That's what this line that I've drawn here. That 6mm takes into account the deck thickness of the plywood. I've removed 6mm at the bottom, which takes into account the keel thickness of the plywood. There's a little flange here where the 6mm thickness of the bottom will change to a 3mm thick plank. I'll show you that in a second. I've also taken 3mm off these edges to account for the thickness of the balsa wood. And I've quite simply done that by tracing that former. And what I end up with for formers 5, 6, 7 and 8 is this simple shape. Okay, so here, this area here is where the 6mm thick plywood keel will sit right across. You can see I've put 89mm from here to the centre line. So in the boat, in the model, in the hull, there'll be a gap twice that, so the span of my fingers there running right up the centre of the boat where we can put radio equipment, things like that, batteries, anything we need. It'll probably need a fair bit of ballast, being such a volumetrically large hull under the water and so flat. So what we've got here is we've got 6mm will add deck to the top of this point here, 3mm will add skin thickness to the outside, and then we're going to add 20 thou plastic to that to make the plating. This little flange here basically is 3mm, and what that does is that's where 3mm balsa wood runs around this radius and meets the 6mm thick plywood keel. So that's a 3mm flange there. I'm going to need to cut 6 of these out. No, I'm not. I'm going to need to cut 8 of them out, I beg your pardon. And you can see immediately by removing this area to the centre line, if I double that, if I'm cutting those 8 of those out, in effect, I've literally saved nearly 2 square feet of plywood at about £6 or £7 per 2 square feet. It's a reasonable saving in cost. So it's worth doing it, and it makes almost no difference whatsoever to the complexity of building the hull. If you're worried about the hull sagging in the centre, we can build some beams across. I'll look at that. I might demo that later. So what I'm going to do over the next couple of hours is I'm going to construct onto this plywood the centerline keel, and then I'll take you through the construction of that shape. I'm also going to construct the deck, which will use exactly the same technique as constructing the centerline keel. So I'll run through an explanation of that. And I'm going to cut a couple of these pieces out, or these 8 pieces out. And that will leave us with formers 9, 10, 11, 12, 13. I might miss former 12 out because it's a half spacing, and it will leave formers 1 to 4 at the front, plus a keel section at the front and rear. So as things progress, we'll turn this wood, if you like, into a kit of parts, and then we'll do an assembly. And when it comes to cutting out the next formers, I'll do a demonstration of creating and producing the, let's say, former 1, 2, 3 or 4, which are slightly different in shape and design, but I know I can use this for 8, you know, twice for each former. Flip mirror image to the other side of the boat, so I need 8 of these, and it'll save me a lot of space. So my first job is I'm going to create the keel shape. What I might do is I might actually show you, I might actually do a video of creating the next couple of formers after this, or what I'm planning on doing. Okay, but I'm going to stop waffling now. I'm going to start creating this shape. Okay,